Uh, Good morning, everyone, and welcome to today's webinar hosted by us, barpa, the impact of AI on ICT infrastructures. It is very, very good to have you all here, and I hope we can match your expectations in terms of this very complex subject. Artificial intelligence is no longer just a buzzword; it is reshaping the way we design, build, and manage ICT systems, from automation and predictive maintenance to smarter, more resilient infrastructures. AI is already setting the foundation for next generation of connectivity. So it's a fascinating and important topic. And to guide us through, we are honored to have here with us Leonardo Martinez, which you can see on the other camera, barpa's head of engineering. He brings extensive expertise in this area and will share with us valuable insights into how AI is transforming this field, as well as the opportunities and challenges ahead. So thank you for joining us. And any doubts, you can ask them through chat or in the end of the webinar. So without further ado, I'll pass the word to Leonardo. Okay. Have a very good webinar.
Thank you, Alexander. Well, good morning and welcome to this seminar. As Alexander said, we will have at the end of the webinar a little Q&A session. So please, if you have any question, put it in the chat, and we will go through them at the end of the section. So, okay, so the subject of this webinar is the impact of the artificial intelligence on structured cabling infrastructure. This title could lead us to two different approaches. One is how the impact is of the use of artificial intelligence in our daily business. That has a big impact on the data that it is managed, because remember, artificial intelligence is all about getting data, as much data as possible, and from this data to learn and to be able to predict actions, futures, and so on. This can be used in a lot of types of business areas like marketing, commercial, including engineering, and so on. The workforce for this type of artificial intelligence is in the data centers, in the artificial intelligence data centers. So there is where we will have a big impact on the infrastructure. But today we want to look at artificial intelligence, how we can use it in our structured cable infrastructures. So where it can be used and how we can benefit from this artificial intelligence to have a better and better structured and better maintained infrastructure. So just quickly the agenda. First point we are going to very quickly is who we are, our golden circle, our history, some reference works. And then we go into the matter and we talk about the impact of artificial intelligence in structured cabling infrastructures, electromagnetic interferences. We will talk just quickly about TCP/IP, just to show how also artificial intelligence can help us there. We will talk about PoE, NPTL, and last but not least, sustainability and high density. So who are we? Well, barpa makes, oops, that was too quick. barpa is part of the Argon group. Argon Group is a Portuguese industrial group based in Oporto, and Argon Group launched in 2016 the barpa brand that at this moment exports to more than 20 countries. And what do we do at barpa? Well, we are dedicated to the design, development, manufacture, and marketing of passive products for cabling, structured cabling networks in copper, fiber, optic systems, and racks and cabinets. So, and one thing that guides us is to, and that's the core of a golden circle. I won't go through it all, but just to make sure you know it, our reason to exist is unite humanity through telecommunications over the generations. And you see it in Spanish. Just a small error. We didn't translate it. Sorry for that. Some reference works we have been honored to work with. Here you can see some of them are in Portugal. One of them is in Budapest, in Hungary. But just to see where we are used, where our materials are used, you can see logistics centers, hotels, in retail, in smart office buildings, and so on. And some of the, let's say, the latest and biggest infrastructures, the Ethnography Museum in Budapest, a hospital in north and west part of Spain, Pontevedra, and also we have a health center in Malta. Just a few examples on installations and on customers that trust on us. So let's get into it. The impact of AI on structured cabling infrastructures. So how can we benefit in our cabling infrastructure from artificial intelligence? Well, first of all, let's consider what is happening in the world with data connectivity. We see in constant growth of users, constant growth of data being used and transported. So in 2023, the estimation is that around 70% of the Earth population is connected to the internet, and that's growing. So we see an exponential data growth with use of artificial intelligence in buildings, cameras, sensors, HVAC systems. Everything communicates and learns, and we use big amounts of data. And the estimation is that by 2025, 75% of enterprise data is expected to be generated at the edge. So really close to it. That will make our data infrastructure being much used and under pressure. So we see that the annual size of the gold ionosphere is increasing exponentially. We are in 175 zettabytes, so that's incredible amount of data being transported. So we have an increase in connected and demanding world. We have more devices, more data, and less room for errors. So what is the impact on the cabling infrastructure? It's under pressure. We have more devices to manage and to control. We have more bandwidth needs. As we are using more and more control systems, the latency has to be much smaller. So we need a lower latency infrastructure. We need an increase of reliability and availability, because all our productions are based on the availability of the data. Okay, and the space is not getting bigger, so we have less space and a higher energy consumption as we put on more devices. So why talk about artificial intelligence and infrastructure, and what can we use it for? Well, AI is already present in a lot of things we use, like our phones, cars, houses, and of course also social media. But you can use AI for automation. So we can through AI we can and sensors we can put on the lights in different spaces by detecting the people in the rooms. But it's more adaptive intelligence. So it's all about learning patterns, seeing when something is not according to these patterns, and by that detecting faults. And detecting faults as possible before the faults happening. So we can also have prediction and make or suggest technical decisions. Immediate benefits of this will be reduced downtime, more operational efficiency, and scalable and sustainable infrastructure. Who doesn't want that? So what are we going to talk about? First of all, we are going to talk about electromagnetic interferences and how that can make our network work slower, and how we can use AI to predict it and to eliminate it. We're going to talk about also the transport layer, as I said, TCP/IP, about PoE and energy efficiency, and how AI can be used for that. And to implement that, we will gonna talk also about NPTL and the changes for terminations of cables. And last but not least, sustainability and high density. So EMI, or electromagnetic interferences, is an disturbance caused by electromagnetic fields that can come from different electrical installations and equipment, and can interfere with our data transmitted. So it can be of different forms, like can be a continuous electromagnetic interference, like from motors in industrial environments, elevators, and so on. Or just punctual, and just spikes, energy spikes that come from different ambients. So common electromagnetic interference sources are electrical motor, transformers, fluorescent lightning, although nowadays they are more and more replaced by LEDs. Industrial machines, elevators, faulty power supplies, radio frequency, like our mobile phones or nearby antennas. And by types, we can differentiate the electromagnetic interference, the conducted electromagnetic interferences that enters through the cable conductors, or radiated by airborne. Of course, the impact that we can have when we are solving electromagnetic interferences is that we increase the bit error rate. The bit error rate is how much bits per transmitted data um, we will have, how much error bits. So just to give you a figure, one bit per a million bits transmitted will make 10 G fall down. It will fall down to gigabit Ethernet. So very, especially very high demanding transmissions like 10 gig will be very subjected to increasing bit error rate and by the end by electromagnetic interferences. So that's why we also have to test for alien crosstalk in 10 gigabit installations, UTP installations. So when the bit error rate increases, that will lead to packet loss and also to packet resends, and that will affect TCP. And we, with a good AI system, we can detect this packet loss and determine where they come from. As we know, we'll know which devices are resending packages because of the interferences. So we can have also intermittent link losses and interferences, of course, on copper cables. So, and this is very crucial in hospital environments or industrial networks and environments with high energy power, like technical rooms. So first of all, what would be good practices when we are having an installation in a potential high ME environment? The good pattern will be use shielded cables, use shielded solution, use good earth bus bars for joining racks to metal structures to earth and for earthing and bonding. Maintain a good physical separation between power and data cable. In the EN Senelec 5174/2, there is a beautiful table that explains this physical separation needed between power and data cables, depending on the type of electrical power circuits I use, depending on the runways we use for installing the cables, and also or the trays, and also the construction of the cable. And of course, more shielded cable with a better shielding will prevent from interference from power cable. So we have several applicable standards on shielding, grounding, and the data cables. And that is the already mentioned Senelec EN 5174/2, ISO the 11801, and AIC 6364 that will talk about grounding and bonding on IT installations. So TCP/IP makes part of the protocol stack that operates into 4 layers. Going from the bottom up, we have the access layer, network layer, transport layer, and application layer. And there we have the transmission control protocol, TCP/IP. And that's the basis of all our internet operations today, and all the equipment we connect to the internet or to a LAN will have a TCP/IP address. So, what are the challenging for the management of a TCP environment? We don't have an artificial intelligence. What we can do is log all the traffic with monitoring tools like sniffers or protocol analyzers. And it's really a big job to dig into it and to find the faulty links or the data that is corrupted and being resent recently. So it's like saying it's an equipment for really experts. So it's very difficult to identify complex errors. Doesn't have any predictive capacity because it's based on logs we already have. So it's not seeing into the future, only can look into the past. So we will have our network operation center and our security operation center really overloaded with if they have to do a diagnostic with it. And as I said, diagnostics will depend on highly experimented technicians. So with artificial intelligence, what we can do is to learn the traffic, construct with artificial intelligence patterns and identify when there are non-normal traffic patterns. So, and it can make us also very aware of deny of service attacks, botnet or intrusion attacks. We can also use it for adaptive optimization, like dynamic loading balancing, and automatic prioritization of traffic with intelligent quality of service configurations. AI can also predict with the tendency of the data is being transmitted or the amount of data being transmitted. It can make models indicate probabilities of degradation or disruption, and at the end can recommend actions to take before the network really collapses. So, as we said at the beginning, AI is all about data. So, as many data we can get, so as more data we can get, better will be the functionality of the artificial intelligence, and so we can be able to predict what is going to happen or detect non-normal behavior. So these data is gathered by sensors, a lot of different sensors in, let's say, using the word of sensor in a very wide sense. And a lot of these sensors will be placed in very difficult accessible places on the edge of the network, closer to the users. So it will be require a very reliable, scalable, and energized infrastructure. So as being in a difficult places to reach, so if we can have an infrastructure that brings to them data and power, then we will have we will be more efficient. And also devices with built-in artificial intelligence as access points with recognition or smart sensors will, and most of the time, operate in sensible areas 24/7 and require more power over Ethernet. So the greater the number of devices, the greater number of PoE ports in simultaneous use, we will have more power consumptions, temperature increase, and also possible interferences. So, and old infrastructures really quickly become insufficient to face the new density and the new amount of power required. And as we see from the market research, the growth in power over Ethernet market is suspected to be almost 23% in annual growth from 2024 to 2032. So, okay, so what is power over Ethernet? Power over Ethernet allows us to take over the same cable data and power to powered equipment. These power transmissions is in direct current, so it will be affected by the resistance of the cable. And not only the resistance of the cable, but also the difference in resistance of the wires in each pair and also between the pairs. So it's a good thing to look when you're trying to choose the data cable is to look at these parameters, and at barpa we are very, very on the safe side of these parameters. Well, what are the common PoE powered devices? The most common are access point, Wi-Fi access points, IP cameras, voice over IP phones. That would be probably one of the first equipments installed with PoE. But now we have a lot of IoT sensors that control temperature, pressures, presence, and so on, and also industrial access panels and controllers. So PoE started off, if I'm not wrong, around 2003 with the capability to supply 15.4 watt at power device 13 watts. So 2 watts will disappear in the cable, normally through heating. That was good enough for a lot of access points, IP cameras, and voice over IP phones. But then we started to put higher demanding access points or cameras with positioning and heating. So PoE Plus came up with the capacity of 30 watts. So PoE became more and more popular, and new and higher demanding devices were designed to be able to use also PoE. So now we have PoE++ up to 100 watt with 17 watt at the powered device. So about between 20 and 30 watts will disappear through dissipation and heating. So what are the challenges with PoE? Well, it's difficult to monitor energy consumptions per port or per device. when you have a PoE device that has, let's say, 8 PoE ports, it doesn't mean that it can supply simultaneously 15 watt on all ports. So as we ask for more and more power, these PoE devices get stressed. So lack of real-time information and operating status will be really a trouble. That makes fault diagnostics very complex. And you don't know when a fault occurs, if it's the injector or the PoE switch, the power device itself, or the cable. So with artificial intelligence, we can learn patterns on the consumption of the devices and see if there is a suddenly increase in consumption that can alert us from some devices going into some type of fault mode. And that will give us the ability to have a predictive maintenance. So, and it can make us recommendations to be able to solve the problems before they really happen. So with artificial intelligence, we also can reduce power consumption by automating processes. We learn patterns of the behavior of people and the presence of people in an installation, and we can switch off devices that are not really necessary when there are no people in. So in an office, for instance, there's no sense to have Wi-Fi connected when nobody is in there. So AI can learn these patterns and take for us these type of decisions. An important point to take into account when you use PoE is that all components have to be PoE ready. For cables, it's very easy because the cables should be or should have a good resistance performance, and also resistance imbalance should be tested to see if there is a difference between resistance in the pairs, between pairs, but also on the wires, the two wires of each pair. In the connectors, we will need also to have PoE compatible connectors. If we don't have these type of connectors, the probability that our connectors will burn down is very high. So what happens if we disconnect the patch cord from a powered device is that at the moment we detach the connector from the power device, a little arc will cross from the patch cord tips to the connector contacts. This, of course, we didn't make the first step, that is to our management system, disconnect the PoE power device. But to be honest, not always people work that way. So they disconnect directly the patch cord, and a little arc will spring from the connections. If this just happens one time, no problem. If it happens 3 times and the connectors are not PoE prepared, then they will burn down. So please check that part also. If you have a PoE installation, take care and only use PoE prepared connectors. So as we use more and more devices connected, like access points, cameras, IoT and devices, they are normally in difficult places to connect. So already there was a need to install directly a male plug to the end of the cable and have a direct connection from the patch panel to the cable to the device, and not going through a socket or a faceplate and a patch cord. So with the appearance of the MPTL, the modular plug terminated link, we remove unnecessary endpoints, and this facilitates the installation of difficult installations. We will have less space in telecom boxes, and we will have increased security. And as already from 2018, we have a norm, and we can test it as we see it a little bit later on. So MPTL stands for modular plug terminated link, and it is a direct connection. So we have a direct connection from the patch panel for the connector in the patch panel cable, and direct to a male connector, and not using a patch cord socket, permanent link, and a patch panel. So in MPTL, the network terminates directly in RJ44 connected plug. So its typical applications are video surveillance cameras, Wi-Fi access points, lab panels, LED panels, industrial IoT equipment, outdoor environments, ceilings, technical walls, and so on. So we have reduction of material, socket and patch cords. Fewer connections mean less chance of failure points, and we have a faster installation. So we have to take care, and when we install them, use the right tools for the field termination. We have to maintain the maximum link length and the channel link length within the 100 meters in total. So that means that we have, depending on the patch cord length we're going to use, that will depend our MPTL link. And use certified and compatible plugs. And then, of course, you use the right configuration for testing, and we will see that later on. Also, as we won't have a data point, we will need to put the label on the cable. As we don't have an outlet with a label, we have to do that on the cable. And especially when we gonna use this MPTL links in industrial environments, we will need to use shielded connectors. And of course, avoid excessive stress and bending near the plug. So One of the main problems we had before we had the NPTL definition is that there was no possibility to test correctly our link with a connector and a field terminated plug. So we could use permanent link, but the problem is that the permanent link adapters are also a male. This means that we cannot attach it to the male field terminated plug ending. We can use channel, but then we will introduce a patch cord, additional patch cord. And the problem we have is that in the channel adapter, by definition and by standard, the last connector is not taken into account. It's not measured. So that would mean that we test our field terminated plug, and the last part, the field terminated plug, will not be tested. So also the permanent link testing is not good, and not also the channel, neither the channel. So for correct certification, we have to use the permanent link in the patch panel connector, female connector, and we have to use the patch cord adapter, patch cord test adapter for the plug part. The thing with the patch cord adapter that we have specific patch cord adapters for category 6 and specific for category 6A. So they are not compatible with between each other. So for each category, we would need a different adapter. And this configuration, the modular plug terminated link configuration, is adopted by the TS standard in the 568.2D standard, also by the ISO EIC 61935/1 and by the Senelec EN 5173 standard. So what about sustainability? We have more and more devices in our network, so we have more consumption, as we have seen. We have more PoE devices. So AI can also help us with that. So demand for connectivity and performance has grown exponentially, as we've seen. Growing need for very high reliability, so that means redundancy and scalability for high performance environment. And we have less and less space for thermal dissipation. Increased complex and modular environments are required. So we have several restraints. And this leads to the need of greater density in the infrastructure. So that leads us to high density, and high density can increase our infrastructure efficiency by enabling more connections in less space and with very high performance. And we will have, as we use also less space, we have less consumptions of material, optimizing energy use, cooling, and so on. So, for instance, we can have high density in optical fiber connections. So we will use more capacity with fewer cables, using MPO and trunk cables, replacing a lot of different cables. Also, these type of solutions will optimize our space in racks and sub-racks, and freeing up space in data center and technical rooms. It will also lead to cleaner, more organized installations, and this also facilitates maintenance and reduces intervention time in data centers. That is also a critical factor for high-end tier 3 and tier 4 installations. And it means also we can have a greater scalability and a better thermal management, as we said before. So MPO means multiple fiber push-on. It's a connector or a system that can hold 12, 16, or 24 fibers and in one connector. And using multiple links, we can go up to 48 or even up to 96 fibers with one single cable. And it enables faster and quick modular connections between panels and even direct to equipment, and is the standard for high-speed infrastructures like 40, 100, or 400 gig. So where can be used? Used, of course, in data centers, edge and cloud data centers, where data is processed in real time, and also for our artificial intelligence infrastructures will be located in there. Hybrid infrastructure, where latency is very, very critical, and we have big amounts of traffic, data traffic. And it's ideal for artificial intelligence, I said, 5G video streaming and high bandwidth applications, and it's a fast and very neat installation. So the best practices, and this is for sure in MPO installations, is a very detailed planning on the layout and polarities we are going to use, and also, of course, the length of the cables we are going to need to install. Can use MPO breakouts to connect different servers, and we can, of course, MPO are always factory made, so we have to define it very carefully. Essential care, the polarity, we have 4 types of polarity, types A, B, C, and universal, and this makes it, it's a not easy matter to determine what the right polarity is and how to maintain the polarity throughout the data center installation. So to have MPO connectors where you in field can change gender and also polarity is highly recommended. So use the Pro version. Like in other optical fibers installations, strictly cleaning of the connectors is not recommended. It's a must. 99% of the cable failures are because of the connectors not being cleaned. Even with new, just from the factory arrived MPO links, we have to clean them before to use them. And we have to, once installed, test them to be sure that the installation has been done correctly. So can also use a trunk and fan out cables, and these are cables that can have on one side MPO, on two sides MPO, or one side MPO and on the other side LC or SC connectors to connect directly to the active equipment. So that makes a quick installation and plug and play installation very reliable, and reduces installation time. The time being on the data center side, like I said, it's critical for tier 3 and tier 4 data centers. So as we said, it's more and more important that infrastructures are designed to be able to support us in the future. So we require to have artificial intelligence, a robust infrastructure, higher bandwidth, with high latency and stable and reliable power. So we have to think about also scalability of future-proof installations. So then we have to think about Cat6a cable and higher structured cabling. We have a lot of emerging technologies coming on the way, like Wi-Fi 7, that brings new challenges, new IoT equipment. Although they don't have a high data throughput, there will be a lot. So at the end, we'll have a lot of data, combining them together. We will have completely seamless integration between wired and wireless networks. And we also have to take care that the wireless networks have a good cable infrastructure that will give them support for not only 10 gig, but upwards. Smart buildings will have a lot of sensors needed and actuators needed to support this, let's say, the smart part of the building. And we will need a more modular and flexible solutions ready for future upgrades. So this all leads to that we have to think, we have to use smart planning, think really long term, and we can even use AI to help us with that. Use good practices to ensure a good installation using good products, oversized products like barpas. Test, certify the installation to be really sure that the installation made is up to what we need in the future, with professional persons that have had the right training, and it also will give trust and credibility towards the end customer. And have a commitment with sustainability, the right decisions to prevent waste tomorrow. So artificial intelligence can make the decisions, but it is the quality of our infrastructure that sustain them. That's our last sentence about artificial intelligence. So thank you for your patience. And if there is any questions, we will open to answer them through our chat. Oh, no, no questions? I think everything was very clear. And then
Yeah, I think so too.
we have no questions left. So thank you for your attention, everybody, and see you next time in the next webinar. And I don't know, Alexander, you want to have the last word?
Yeah, just that thank you again, as Leonardo said, for being here, and that this recording of the webinar will eventually be on our YouTube channel. So if you want to check it again, or if you have some doubt and want to rewatch it, or even share with others, you'll be able to with no problem. But you'll be able to see it whenever it's uploaded. Okay. So yeah, hope you liked it, and a very good business. And do not forget about us when we talk about this subject. Bye bye.
All right.